Dear students, in this lecture we are going to see the concept of clustering, its types and its applications. Also the similarity measures used in clustering algorithms. Clustering is a method of unsupervised learning algorithm. As you know already, what is unsupervised learning? In unsupervised learning, the machine learns through the unlabeled data and discovers the outputs on its own. It doesn't need any external teacher to teach the model. Clustering is a process of grouping similar objects together. Here the objects are grouped based on features, characteristics or pattern which is available in that particular object. The objects in one group should be similar to each other than the object in the other group. Here you see we have a basket of objects. Here the objects can be either grouped based on the color or shape or size. And here you see here the objects or the different balls are there. These balls are grouped based on their pattern. So the model can able to find the similar structures in the collection of unlabeled data. So the objects in the one group is not same as the object in the another group in terms of its characteristics or in pattern. In clustering, we have two terminologies. One is called as intra-cluster and another one is called as inter-cluster. Intra-cluster is nothing but within the cluster, inter-cluster is nothing but between the cluster. In intra-cluster, the objects within the cluster are similar. So the distance between two objects are very similar. In intra-cluster, the distance between two objects are minimum. So there is a high intra-cluster similarity. But in consider with inter-cluster, the objects in different clusters are different. So the inter-cluster similarity is less. So the distance between the inter-clusters are maximized. Now consider a problem statement. You are managing a PlayStation store and you want to find out the preference of your user in order to improve your business. So the question is, how will you devise a unique business strategy for each one of the customer who is using the PlayStation store? The solution for this is the clustering algorithm. Let us consider the applications are grouped into three categories. That is, the cluster 1 contains the user who are interested in sports. Cluster 2 contains the female candidates who are interested in video games. Cluster 3 contains the male candidates who are interested in video games. And here these groups are formed based on the profile information and their interest and their activity happen in the particular application. So based on their usage habits, we can able to now devise a separate strategy for the users in each of these groups. In order to do that, the clustering algorithm is the backbone of this. Mainly the clustering algorithm is divided into two types. First one is hierarchical clustering and the second one is partitional clustering. In hierarchical clustering, the data are organized in hierarchical manner. Either the data can be grouped in the bottom-up direction or the data can be split in a top-down manner. Example for hierarchical clustering is agglomerative clustering and divisive clustering. In partitional clustering, the clustering starts with the random partition of data first and these clusterings are refined in iterative manner. Here this algorithm is otherwise called as flat clustering. The example of these clustering are k-means, fuzzy c-means and spectral clustering. Clustering can be also divided into hard clustering and soft clustering. Hard clustering means every object belongs to exactly only one cluster. The example of this clustering is k-means algorithm. Soft clustering means an object may belong to more than one cluster. Example is fuzzy c-means. Now we will see the application of clustering. The first application is the recommendation engine. You have seen all our e-commerce websites such as Amazon, Flipkart, which will recommend the similar product to purchase based on the user interest and the activities happened in their website. Also the Netflix and YouTube recommend the movies to be watched. The next application is the market segmentation. Here the clustering is used to characterize the customer groups based on their purchasing patterns. Based on the product you purchased, if the other person also purchased the same type of category, so it will give a recommendation and also it will categorize that people into one group of purchase pattern. The next application is the social network analysis. Here the clustering is used to recognize the communities within large group of people. You have seen in Facebook, you have a friend, the friend have a list of friends, so you can able to now create a community with large group of peoples. The example are LinkedIn, Twitter, Instagram, YouTube, etc. The next application is the search result grouping. Here the clustering is used to provide a search pages which is most relevant to the keyword among all the pages. So here the pages are ranked based on the ranking algorithm. So the page which contain highest ranking, that will be displayed first. So you all experience with the Google search. So in the Google search you type a keyword, so automatically the keyword related pages will be displayed first. Here the next application is the medical imaging. Here the clustering is used to locate tumors in the medical images. The next application is the image segmentation. Here the image is partitioned into various number of segments using clustering algorithm. So different regions in the images represent different color code based on the similarity available in that region. The next application is the anomaly detection. It is nothing but identification of rare events. For example, by getting the logs of the website usage, you can able to detect some unknown network intrusion activities in the network. Also, in banking, by getting the logs of transactions, we can able to detect whether it is a fault transaction or it is a normal transaction. These are the some of the applications of the clustering algorithm. So now we have some similarity and the distance measure in order to find out the similarity between the two objects in the clustering algorithm. Because the grouping require some methods to compute the distance or similarity between the two objects. There are some classical methods which is used to measure the distance. One is called as Euclidean distance matrix and another one is Manhattan matrix. Already you know about Euclidean distance matrix. And these metrics are coming from the base matrix called as Min-Hoshi matrix, and this matrix is represented by xi minus yi the whole power q and that sigma whole power 1 by q. When you substitute q equal to 1, this leads to the Manhattan matrix, which is nothing but summation of modulus of xi minus yi. When you substitute q equal to 2, this equation leads to the Euclidean matrix. You know about square root of sigma xi minus yi the whole square. When you substitute q equal to infinity, this leads to the other metric called as Chebyshev matrix, and which will find the maximum distance among the 2 points. So now we'll consider one example. So here 2 points are given, point P1, point P2. According to the Euclidean distance, the distance between the 2 points is calculated by square root of x1 minus y1 the whole square plus x2 minus y2 the whole square. That value leads to 5. When considered with the Manhattan distance, which is nothing but modulus of x1 minus y1 plus x2 minus y2. So it will yield the result of 7. But basically in all the clustering algorithm, Euclidean distance is used as the similarity measures. Thank you for your attention.